Lesson 9.5, Coordinate Proof. We can classify figures in the coordinate plane using the formulas for slope, distance, and midpoint. So first let's talk about distance. If you remember, here's your distance formula. What this does is it finds the length of a segment. This can be very helpful to use to prove two sides to be congruent. Your next formula that you have is your midpoint formula. Remember that this finds the exact middle of a segment, and this can be very useful to prove that a segment has been bisected. Finally, we have your slope formula. And this finds the slope of a segment, and it can be used to prove that sides are parallel, meaning that the slopes are the same, or that sides are perpendicular because the slopes are opposite reciprocals. Take a minute, stop the video, and make sure that you have this chart filled out as easy reference. If we're given a set of coordinates, we can classify the quadrilateral using these tools as a parallelogram, rectangle, rhombus, square, trapezoid, isosceles trapezoid, trapezium, or kite. So you've got valid proof strategies in the last section, but I kind of like this two-step method. First, you're going to find the slope of all four sides. This helps you group it as either a parallelogram, a trapezoid, or a trapezium. Within each category, there are special figures, and you've got a little more work to do, but you can also see it from the slopes if any of the sides are perpendicular, and that may be helpful if you're trying to prove something to be a rectangle or a square. Your second step is to look at the length of each side. This helps you classify it more specifically, like a rhombus or an isosceles trapezoid or a kite. So let's do some examples. Okay, the first one gives us 4 points, and it gives us a grid to graph on it. So pause the video and graph the quadrilateral. Hopefully you caught that you needed to create quadrilateral ABDC, not ABCD, because it can't cross back on itself, or it wouldn't be a polygon. So let's start by finding the slopes. Since we have this on a grid, we can actually use rise over run to count our slopes. So the slope of side AB would be 0 because it's a horizontal line. The slope of side BD, because it's a vertical line, would be undefined. The slope of side CD, also horizontal, so it would be 0. And the slope of side AC, it has a negative slope, and we're going to count rise over run. So up 1, 2, 3, 4, 5, over 1, 2, 3, 4. So it has a slope of negative 5/4. The question you ask yourself now is, do I have any pairs of parallel sides? And yes, I do. I have one pair of parallel sides. So based on that, I know it is some sort of a trapezoid. The question we need to ask ourselves now is, are the non-parallel sides congruent? If they are, this would be an isosceles trapezoid. Remembering that geometry is all about proof, we need to be able to show whether they are or are not congruent. Simply looking at them and saying, yeah, I don't think they are, is not good enough. So we're going to go find the length of AC and the length of BD. Using the points that we were given, we put in our x2 minus x1 plus squared plus y2 minus y1 squared. 2 plus 2 is 4. 4 squared is 16. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. So what we found here is that we have the square root of 41. So now stop the video and go do the same thing to find the length of BD. From this we can see that clearly AC and BD are not congruent, meaning that ABDC is a trapezoid. Now let's go look at the second example. Stop the video for a minute and graph points. Okay, so here's our figure. Let's go calculate the slopes of each of the sides. I've grouped these with the sides that are across from each other, so it'll be easy to tell whether the corresponding sides are parallel. So EF has a positive slope. We would go up 2 over 3, so that's a slope of 2/3. For at GH, again positive, up 2 over 3. So we know that these two are parallel. FG has a negative slope. We would go up 1, 2, 3, 4 over 1. So that's a slope of -4. And EH, again negative, up 1, 2, 3, 4 over 1. Also a slope of -4. So those two are parallel. Since we have two sets of parallel sides, we know we have some sort of parallelogram. So now let's use, we're going to use distance to find our side lengths, because I know it's a parallelogram and I can see that my sides are not perpendicular. So I know it's not a rectangle or a square, but it could be a rhombus if all of my side lengths are the same length. So again, let's go find the length of EF, and then we'll go find the length of each 4 of these sides. So stop the video and set those up. Start the video again once you've calculated your side lengths. Hopefully you found that EF and GH were congruent and FG and EH were congruent, but they're not all 4 congruent. So what we found is that EFGH is a parallelogram. Since we would need all 4 sides congruent to be a rhombus, once we got the length of FG to be different from EF and GH, we could have stopped and stated that that was enough to prove that it was not a rhombus. Okay, let's move on to the next one. Go ahead and I want you to graph this and find your slopes. Okay, so here's our figure, and by calculating slopes, even when I look at opposite sides, I can see that none of my sides are parallel. This has no parallel sides, which means this is some sort of a trapezium. Next question we have to ask ourselves is it a kite? It may also be interesting to note that right now I can tell that ML and LK are perpendicular. That's not really going to matter for this, since there's no way it could be a rectangle, but that is interesting to notice anyway. So to test to see if it's a kite, I need to find out if ML is congruent to LK and MJ is congruent to KJ. So let's go find our side lengths so that we can do that. Okay, so here are our side lengths, and we are able to see that ML is congruent to LK and that MJ is congruent to KJ, which means that JKLM is a kite. Okay. The next one we're going to skip for a minute. We'll come back to that one. But what on number 5? In fact, and let me just talk about 4 real fast. 4 is one that I'm going to leave for you to do on your own. This doesn't have a grid with it, so you may want to wait until we look at the next one, which is similar. But you'll come back and do this one on your own. So 5 just lists the points. It doesn't give us a grid. The problem isn't any different. We know what we need are the slopes of each of the sides, and we need the lengths of the sides to be able to classify this. So let's go through and calculate slopes first. So our quadrilateral is RSTU, so what we need is the slope of side RS, ST. Well, let's go ahead and pair the ones that would be opposite. RS would be opposite, well, our next one would be ST, then TU, and U back to R. Okay, so let's go calculate our slopes. Without the grid, we can't really count rise over run, but we do have our slope formula, and that's change in Y over change in X, or Y2 minus Y1 over X2 minus X1. So when I'm looking at R and S, I'm going to do my Y value minus my Y value over X value minus X value. On the top, that's a -6. The bottom is a 1. We've got a mistake right here. That's not a 4. That should be a 1. y minus y, which is of course going to change this. That's going to give me a negative 3 on top over 1, which is the slope of negative 3. So let's go look at TU. That's going to be these 2 points. We're going to again do y minus y over x minus x. That's an 8. So we're going to get 3 over negative 2, or negative 2/3. Okay, so those are not parallel. Let's move on to the next one. ST is going to be these 2. So we'll have 8 plus 2, 8 minus negative 2, or I'm sorry, 0 minus negative 2, over 8 minus 5 would be 2/3. And if you look at these 2, my slopes are opposite reciprocal, so I know that those are perpendicular. You are, so I'm looking at this pair. So it'll be 3 minus 1 over 6 minus 4, which is 2 over 2, or 1. So remember, we're going to use those slopes to make our first determination. I have no parallel sides, which means this is some sort of trapezium. So the next question we have to ask ourselves is it a kite? To do that, we're going to have to test our side lengths. So let's go through and do that. We've had lots of practice at this point calculating side lengths, so stop the video for a minute and go calculate your side lengths. What we find here is that we have one pair of congruent sides, but not two. To be a kite, I would have to have both pairs parallel. So what we find is that what we have here is a trapezium. And this was RSTU. And there's our finding right here. Again, you're going to do the same thing with 6. You're going to go through those practice problems there. Try this one on your own as well, and your teacher's going to check that in class. Okay, so let's go look at this last page now, because this is a little bit different. We're going to do 8 and 9 together and let you do 7 and 10 on your own. Basically what they've done here is you're using properties of your quadrilaterals. They're telling us that it's a rhombus. So what that means is I know all my sides are congruent, but they're giving me information about AC and BD. Those are the diagonals. So now we have to think about what do we know about the diagonals of a rhombus. And if you need to flip back in your chart, go ahead and do so. Make sure that you know what properties you're looking for. And for a rhombus, we know that our diagonals are perpendicular, but also because it's a parallelogram, we know that our diagonals bisect each other, which means if this distance is 6q, then each one has to be half of that. This is going to be 3q, and this is going to be 3q. So the coordinate of A would be negative 3q, 0. C would be 3q, 0. We can go through the same logic on BD. If this distance up and down is 10r, then each half would have to be 5r. So the coordinates of B would be 0, 5r, and D would be 0, negative 5r. All right, let's look at 9. And this is the same kind of deal, but we only have one to find here. We need the coordinates of E. Well, we can see that the y-coordinate is the same y-coordinate that we have for this point right here. So I know this is going to need to be 8b. To get your x-coordinate, what you want to look at is this. You've got this whole distance as 6c. We know that this distance is 8a. We can tell by the way this is set up that this is an isosceles trapezoid, plus they've told us right here that it is. So I know that this would also be 8a. So to get my coordinates of E, I would do 6c minus 8a. All right, the problems that we haven't done you should do on your own. Finish off your notes and then get your Tier 1 and knowledge check done.